Now let's review our figure 20-38 from Stallcup's Electrical Design Book, Volume 2. And notice we're dealing with a transformer located outside. Who does it belong to? Does this transformer belong to the owner of the facility, or is it a utility transformer? Well, in this case, we're saying it belongs to the owner. They own this transformer, and they have a feeder coming from a substation where the service equipment is located. By definition, a service point in Article 100 of the code. And this is a high voltage feeder, over 1,000 volts, 13,800 volts, three-phase. And notice 300.50 deals with this feeder and deals with the say conduit cable, whatever it may be, say. And then underground, on the secondary side of that transformer, we'd look at 300.5, which deals with 1,000 volts or less, basically, as well as your 300.50 on the primary side. That feeder would deal with a system over 1,000 volts. Now notice there's no restriction to the length of that run for the primary, and there's no distance for the run on the secondary underground until you enter the building. Now when you enter the building, we'd be looking at 230.70 in this case. And of course you want to set up your overcurrent protection and disconnecting means immediately, as soon as practical there when you enter in, see. So exactly what are the requirements here? Well, let's look at note 1 in the illustration. Transformer output is 300 amps on that secondary. We have 350 kc mil conductors rated at 310 amps each. So the 310 takes care of the 300. And then we have figures that we refer you to, figure 9-28, 16-57, with more information that would be helpful with this illustration. But now notice sizing the conductors, and we're going to use THWN copper. And this is the secondary side, 277-480. And 300 amp requires 350 kc mil conductors. So the solution, we would have 350 kc mil conductors, 310 amps each, which would take care of that load. Now, sizing the overcurrent device in the second boxed in information with a title here, sizing the overcurrent device upon secondary output. Then we'd have 300 amp output requires a 300 amp overcurrent protection device, and that's solution. The overcurrent device is 300. Now notice the overcurrent protection device will protect the 350 kc mil conductors at 310 and protect that output at 300. So this would be a installation that would comply with 240.21 C as in car 4, and this is exactly what our figure 20-38 is illustrating to the designer and installer when they have a transformer located outside with a primary supplied from a substation service gear or equipment, which is identified as service point in Article 100, and the secondary side of the transformer supplying the equipment inside the building. And that's exactly what our figure 20-38 is illustrating.